Hello guys, I welcome you all to my YouTube channel, and today we're going to discuss about normal distribution. So normal distribution is a probabilistic function that describe how the values of a variable are distributed. Before describing normal distribution, I'll be going through discrete distribution and continuous distribution, right? So suppose we considered a sample space of a rolling of a dice. So the outcome could be 1, 2, 3, 4, 5, 6, any one of them, right? So the probability of coming 1 would be 1 by 6. The probability of coming 2 would be 1 by 6. They would be same, and they are very discrete. Like the probability of 1 would be different, probability of 3 would be different. Although they are same, but they would be different, right? Suppose if we consider the probability of number which is coming, which is divisible by 2, would be different from the probability of a number which is divisible by 3. Suppose the probability of number which is divisible by 2 are 2, 4 and 6, and the numbers which are divisible by 3 and are coming by rolling the dice are 3 and 6, right? So here the probability is 1 by 2, here the probability is 1 by 3. So in the discrete distribution, the numbers are discreted numerically, like a perfect integer. And if we consider the case of uniform distribution, right? So in the uniform distribution, suppose these are the x values and this is the y-axis of the probability. So these are all the values, like, right? And it have probability distribution of 0.25. So we consider any value on this x-axis, the value would be the in the probability distribution of 0.25, right? So these are two probability distribution. One was discrete probability distribution, another one was uniform distribution, right? Now if you take an example of normal distribution, so every natural phenomena will follow the normal distribution because the data is always normally distributed. Suppose if I take an example of marks of the student in a particular exam, the marks around the average would be the frequency of the marks around the average would be very large compared to the endpoints, right? Suppose uh, the marks distribution is from 0 to 100, 10, 20, 50, 60, 70, 80, like that, right? So it would be like this. The marks around 70 would be very larger. Between 60 to 70 would be larger, the frequency, right? The probability of the marks coming between 60 to 70 is very larger because this is the mean of the marks of the students, right? And the marks that are very low, that are very high, are very low, right? So we have two terms here. One is mean and another one is variance. So mean is basically the average of the marks, right? And variance is the spread of the marks on the plot, on the normal curve. So if we consider a normal curve, then it would be something like this. In the bell shape curve, it's a bell shape curve. So at the maximum, it would be the mean, and the spread here would be the variance. So it would be mu minus variance, it would be mu plus variance, right? Now let's see this thing practically by plotting on the histogram. We'll see it, right? Suppose I'll be taking normal distribution data and will be plotting on a histogram. Let's see whether it will be coming in the bell shape curve or not. So for that I'll be importing matplotlib by plot splt, and for data I will be needing numpy, right? So data would be np.random np.random.randan and we'll be getting around data of 100 entities, right? Now let's see the data. See the data shape first. It is 100, right? And let's see the data. You can't say anything about the data. Now let's visualize this data. plt.histogram data, right? plt.show. Now you can see the mean is 0 and the variance is 1. So the data, so what we can do, we can increase the bucket size. Let's take the bucket size to be 70, or let's take it 40, right? So the data around 0 is larger compared to the other, and the variance is 1. It is distributed with a variance of 1, right? So if I increase the data also, and the bucket size should be the same, so it would be like this. So suppose if we want to shift our this particular normal distribution curve, suppose what I got from here is the normal distribution like this. Suppose I want to shift it from here to here, then what I need to shift the mean, right? I need to shift the mean. And what if I want to, what will happen if I increase or decrease the variance? So by increasing and decreasing the variance, the spread will increase or decrease. So if I increase the variance, then what will happen? The curve would be like this. And if I decrease the variance, then the spread would also decrease and the curve would look like this, right? So let's see. If I say uh, mu equals to 3, right, that is mean, and variance equals to 2. So to getting the data with mean equals to 3 and variance to be 2, I need to do some mathematical function. Okay, variance equals to 2, right? Yeah. Now as you can see here, the variance is the mean is 3, right? And the variance is around 2. You can clearly see from here, right? So this is what the data is about, and the density is much larger around the mean, right? So definitely we can say the density would be higher around the mean and would be lower if we go beyond the variance. If we go beyond the variance, both the sides, right? So this is the basic representation. You can try by alternating these mean variance value, or by changing the number of data points, by changing the bucket size. You can check it and visualize to make a better sense for you, right? So this is the case for every data. Like whatever natural phenomenal data around the environment is, they all follow the normal distribution, right? So that's all about normal distribution. Thank you so much.